Hi everybody. Next we are going to discuss about the 89C51 microcontroller introduction. How we can use the 89C51 microcontroller. You can see one by one. So this is the memory. So we already seen the block diagram and everything. So this is a memory part. So mainly the microcontroller memory, like I said, typically it's a microcontroller architecture is dedicated to strong data or programming instructions. So storing data or the program instruction we can store in the memory. Mainly the program memory, that is ROM or flash memory we are using, and the data memory, that is RAM we are using, and the registers and the special function register, that is SFRs we can use, and then electrically erasable program read only memory, that is EEPROM also we can use. This is a main major memory device. So the memory is very important for every electron devices. Based on the memory, it will be working, and the function it will be doing. Whatever we given the instruction, it will be stored in the memory. So memory type may be vary, but the memory is needed for each and every microcontroller. So based on the application specific and what we needed, so we can choose the memory ROM or RAM or EEPRAM or SFRs. That's a special function register. We can choose anyway, but the memory is needed. And a program, that is a ROM or flash, this is the memory. It will be program instructions that in the microcontroller execute, and usually non-volatile memory, meaning that stored program remains even when the power turn off. That is called as a non-volatile. Once we power off, so that memory instruction everything is stored and will be available for the next execution. So it will be called as a non-volatile memory, that is ROM. And depending on the microcontroller, the memory block may be implemented by using the read-only memory, that is ROM. That's a main important difference. And microcontroller data memory is a ROM is a temporary storage. This the memory is a block used for the storing the data. The microcontroller is manipulates during the program or execution. And the random access memory typically volatile and stored consists of low, then the power will be turned off. That's the main data memory. And also the registers are a small high-speed memory location within the CPU, that central processing unit of the microcontroller. So automatically the user the holding data is temporarily during the program of execution, as well as the storing the control of information and registering the critical rotation of the operations and of the microprocessor, provided for the fast access of data, that is the efficient execution of the instruction is nothing but the main function of the register. Microcontroller mainly the fast execution, holding the data the temporarily. This is the main function of the registers. And the special function register, that is SFRs, the other thing, that's a special function, the memory mapper, the register that control the various hardware peripherals of the features and the microcontroller. The registers are typically located in the separate memory blocks, and they provide the access of peripherals such as I/O port, timers, counters, serial communication, and other interrupt controller, and the power management unit are mainly used in the serial function of there's a special function register, that is SFRs. Mainly the EEPROM, that the electrically erasable program read-only memory, is a memory to include the non-volatile data, store the information, and allows the data to return the erased electrically erasable memory, and making it suitable for storing the information, and calibration of data and other peripheral that can be needed even in the power is removed. That is the main function of electrically erasable programmable read-only memory. And I/O ports, mainly based on the I/O port, the microcontroller block diagrams, that typically it represents the input I/O port and the interface of microcontroller unit. The I/O ports is essential component that allows the microcontroller to communicate with the external devices such as sensors, display, memory modules, and other peripheral devices. Based on the input, it will react by the interconnection of I/O ports. You can able to interconnect the devices. And the timer is basically represent the timer or counter modules is present within the microcontroller. So automatically the timer control the microprocessor used in the measuring of time intervals and generating the time delay and performing various time related tasks on the embedded system in the application. So time related tasks and other time delays will be generated by the several applications. We can improve the timers thing. And AD converter, that's analog to digital converter, basically the typical representations of analog digital converter, all they represent within the microprocessor or microcontroller. Analog digital is a crucial component that microcontroller are used to converting analog signal into digital values That can be basically by the digital circuit another microcontroller unit, and it will be very useful. So this is the main function of the analog to digital converter. And the serial I/O port mainly the basic typical representation of serial communication interface and the present within the microcontroller, and also the transmitting data sequential over the single wire and the communication channel within the bit. And the contrast with the portal and the parallel communication while the multiple bits are sent to the simultaneously or even multiple wires. And otherwise, the other devices generally they refers to external hardware, the components and peripheral interfaces with the microcontroller and external function and the capabilities. Those devices can vary widely depending on the specific applications and required for the some microcontroller system. These are the main serial I/O port of microcontroller. Thank you.